Thanks, Lucy. The next session is on career experiences and journeys. And our first speaker is Shi Ching in Perth, talking about playing in the cosmic backyard, a statistician's journey into astronomy.
No, you're going to see that. Okay, everyone can see the screen, I hope. So yeah, thanks for this chance for me to talk. You're going to hear a lot from me. I apologize. And in fact, I'm going to apologize even more because this is going to be a very self-indulgent talk all about me. So please excuse that. So I'm a PhD student here at Curtin University. I'm straddling between applied statistics and astronomy. So this area of astrostatistics. And so I'm going to talk a little bit about how I got there and why I'm going to unashamedly try and proselytize you all to join me in astrostatistics. Okay. If some of you might know from the title of my talk, it's borrowed from this quotation from John Tukey. The best thing about being a statistician is that you get to play in everyone's backyard. And what I think he's getting at is the ubiquity of statistics means that as a statistician, you can work in many different domains, but you have to still choose a domain, right? And for me, this quotation has an extra dimension to it because I'm literally working on data in all of our backyards, which is the Milky Way galaxy, right? So this figure is from one of my manuscripts where it's depicting the galactic bulge of the Milky Way, which is the glowing part in the middle, and the various X-ray binary systems I happen to be analyzing at the time. So this is going to be unashamedly about all of our backyards, but I'm only going to talk about it from the perspective of an astrostatistician. So my journey so far, this is a bit of a timeline. Obviously, it's not to scale. Just to let you know how I came to this place. So the universe started, and then I did an undergraduate in computer science, worked in private software companies for a while, went back to study into applied statistics because I found myself working with a lot of data from our clients and not really doing it in a responsible way. Ethically, but not responsibly, that makes sense. Statistically, not responsibly. And then I started working part-time as a biostatistician, so in medical studies, and then now doing my PhD in astrostatistics here at Curtin. And so what I want to point out is that my training isn't in physics or astronomy, astrophysics at all. Although I did do a one-semester project during my master's that was related to cosmology and statistics. Don't ask me what it's about. I've forgotten all of that already. But my point is, and I think most of you know this already, and certainly John Tukey knew it, is that as statisticians, we have a skill set that means we can sort of slide into many domains, probably more easily than other people who are trained in some other substantive discipline like chemistry or biology or psychology. I mean, if I can move laterally into a new domain without any, particular training, you can do it too. So what I'm going to do, obviously I can't cover all of astrostatistics in 10 minutes, so I'm going to give us a really high overview of something that you might want to know if you're considering making this jump into astrostatistics, which I think is one of the lesser known areas of statistics, but I think it's a growing field. So I'm going to talk about academic astronomers, and I'll talk a little bit about the kind of data you're going to encounter in astrostatistics, and lastly, some of the practices that you might encounter for good or for ill when you start working with astronomers. But just to clarify, when I mean astrostatistics, it can mean different things to different people. I like these two definitions, which from recent papers. The first one just highlights the fact that astrostatistics is interdisciplinary, right? So it is about taking very complementary data skills and applying it into astronomy, but all the while remembering the second definition up there, which is that it is to a particular purpose, right? There is a scientific agenda, which is to try and quantify and understand the properties of our universe. So we must never forget that if you're going to work in astrostatistics, because the astronomers don't really care so much that you've got a wonderful, unbiased estimator. They want to know, did you actually find a neutron star or not? So let's talk about academic astronomers. So they're mostly trained in physics, so they're quite numerate, but statistics is not part of their formal training usually. So often they learn statistics just out of necessity, so they're self-taught, which means they don't really understand some of the nuances of statistics. They'll just take things off the shelf. They won't know what assumptions to check for. And so that's where a statistician can bring a lot of value in to try and improve the precision or the robustness of any kind of conclusions they come with. But they're very good programmers, right? So they're particularly in astronomy, they use a lot of Python. R is a bit on the nose, unfortunately, but they use a lot of Python. So they can generally program very, very well. So that's already a big plus. And the other thing, as demonstrated by this thing on this figure on the right, is that they often have very, very large collaborations, right? So this is a manuscript just recently published on the archive, a preprint, which is to do with Euclid, which was this space telescope that was launched last year. Huge collaborations. So there's lots of opportunities for you to travel internationally to meet collaborators and work with them, because there is really no private astronomy; it's all publicly funded. But just imagine trying to wrangle that many co-authors to read through your manuscript to get it published. So it can be a little bit trying sometimes. But because it's all publicly funded, everything is on the archive, right? So you're never going to come across, so there's a particular paper I want, it's going to be behind some kind of paywall. It's all available. Code is available, data is available, publication is available. I haven't found another discipline which is quite in the same degree of openness. So it's actually a really great discipline to work in, particularly as a student. Something that we have in common is that they're just as bad at naming things as we are. So we have type 1 and type 2 errors, which tell you nothing about the kinds of errors. Well, they have type 1, type 2 supernovae. But then you have type 1a, and I just want to point out that on this right column, it talks about the mechanism, about how this supernovae forms. So there are some types of type 1 which are more similar to type 2 than our type 1. So why isn't this down here with the other ones? It just doesn't make any sense. But if you're coming over from statistics into any discipline, but I think astronomy in particular, they have a whole raft of jargon and naming conventions that will make no sense because they're inherited from history from the very earliest astronomical practitioners. So that's a little bit of a hurdle that I had to overcome, and you would have to do that too. But I think if you've worked in consulting, you know that's kind of par for the course. So as for the data, it's all observational data, right? No one's conducting experiments on black holes, right? So it's all observational data, and data sets are very, very different, from very, very small ones to massive ones, and their quality is also very varied because it's purely observational. So on the right here are 2 time series of the brightness of a particular source in the sky. Some of them are very nicely sampled, some of them have huge gaps. But I will point out that astronomers and physicists more broadly too, but especially astronomers, because they have to build their own apparatus to observe these objects in the sky, they can characterize their instrumentation very well, or they try to. So every data set often will have these error bars. They'll have an idea of not only the point estimate of what this brightness of the star is, but also the rough standard error in that. And you can incorporate that into your model. So that's actually really nice. I didn't encounter a lot of that in medical research. And so you can... It probably, and I'll talk about next, influence the kind of models they like to fit. But the noise often is heteroscedastic, so we can't assume similar variance across everything. The other thing, we had lots of talks about missingness already, so I won't dwell on this. But you can imagine there are certain parts of the sky that are not always visible all the time, right? So you're not getting random samples of sources in the sky. So here's a visualization of the Vera Rubin Observatory, which is based in Chile. It's in the southern hemisphere. You can only see the southern sky. So when it does a nightly survey of the entire sky, it's only seeing half the sky. So when you do a population study of what it sees, you have to bear those kinds of things in mind. Right. So that's how there is actually huge gaps in the data set, and you have to make sure that if you're inheriting data from another study, you be careful of that. But we, as statisticians, we're good at that already. So just to finish off, so statistical practice, because we're talking about physics, they have a lot of mechanistic models. The laws of physics are the same on Earth, and experiments on Earth as they are out there in deep space. And so often you will find in astrostatistics, we're fitting models onto data points, and they care about how close that fits. And if the data doesn't fit the model, they're going to hold on to the model first because there's a physical basis for that. So they're much more interested in expansion models rather than predictive ones, so you'll notice that. And because there are some certain constraints in the physical world, like the speed of light, say, they go to inform things like Bayesian hierarchical models with very strong priors, with very strict limits. So that's all I'll say about that. They do like to experiment with new techniques because, you know, if you misclassify a supernova, no one's going to suffer. So what can you bring as a statistician? Look, all the typical techniques you use already, it can be applied in astrophysics. And this is just the word cloud from what Canadian astronomers wanted when they responded to these kind of questions. Nothing on there should be too foreign to you. And so all you need to do is pick up a little bit of astrophysical knowledge, and that would be all you'd have to get up to speed. This is just, when I share the slides, you can have a look at the communities out there. These are the references if you want to get a sort of a state of the art of what astrostatistics is like nowadays. And lastly, I'll finish with this particular quotation. Don't forget that statisticians are the freest of all scientists. They can work on anything. So why not be like me and be a statistician? Thanks.
Thanks very much, Xiqing. As an ex-physicist, I have to agree, physics is great. And we are really good at errors. Our next speaker is in Christchurch. Their name is Kung Guglani, and they will be speaking about the influence of statistics anxiety on academic learning. And I'll just butt in when you have 1 minute to go, okay?
I would like to express my heartfelt gratitude to the Society of Australia for their generous financial support, which enabled me to attend this conference in Christchurch. This opportunity has given invaluable experience for my academic growth. Special thanks to my professors, mentors, and peers for their guidance, and also special thanks to ECSSC 2024 organizers and definitely my family. I would like to start with a tale. Meet a girl, maybe me, I'm not revealing, a student who had always excelled in her studies, either it's physics, chemistry, or solving complex mathematical problem. And then one day her academic advisor consulted her and advised her, I think you are ready for the next challenge, and that can be stats. Now, the girl was quite confident because numbers were her good friends. And then professor started talking about Markov chains, confidence intervals, and Bayesian priors, and blah, blah, blah. And the girl thought it seemed like a sophisticated dinner party where everyone was talking in riddles. And the girl wondered, why are all these variables so uncertain? Can't they just be certain for once? And then girl thought, now she can't let go statistics out of her. So she turned concept into game, sorting out patterns and find new ways to explore the world. What I wondered is that the girl found a newfound appreciation for stat. It wasn't just about numbers, it was about uncovering hidden stories they tell. In today's session, I would like to address how addressing stat anxiety can definitely help statisticians and can help them making confident data explorers. That's me, I'm Kunj. I'm currently doing Master of Statistics at Australian National University. Today I will be talking about impact of stats anxiety on academic learning. What is stats anxiety? It's definitely the feeling of worry, fear, or apprehension that students experience when they are dealing with statistics, or basically they have the fear of getting themselves enrolled in stats courses. Some of the various data insights that I found on Google definitely, that 75% to 80% of the students report high statistic anxiety. The last one is the interesting one. Students with maths anxiety may actually perform better because it pushes them to work harder to avoid failing. This extra effort can improve exam preparation. However, while stat anxiety, mathematical anxiety can also have a negative contribution to performance. Stat anxiety led to higher procrastination in the structural equation model and therefore contributing indirectly negatively to the performance. There is a famous paper being titled as The Old Devil Called Statistics. It's been published in 2022, and it was found that, sorry, I'm not offending people, female students reported significantly higher stats anxiety compared to male students. Let's talk about stars. These are not the stars in the sky. STAR is basically SATS anxiety rating scale. It's a tool, and it's being published in the same paper that is being titled as Old Devil Called Statistics. This tool is being validated on Solivian students, and this tool basically measures 6 dimensions of stat anxiety. Some of them include test and class anxiety, interpretation anxiety, fear of statistics from teachers, and fear of stats computation, and fear of stats conduct. I don't know what you guys feel. For me, sometimes I feel our stats teacher are quite firm and strict. So maybe, I don't know. Now, consequences of unaddressing stat anxiety. Reduced academic pressure, decreased self-confidence, long-term career impact, prolonged stress and mental health issue, and definitely avoidance of data-driven courses. Reason for stat anxiety, I think the major reason is lack of confidence in mathematical skills, high grading pressure, time constraints, specifically for university students who are dealing with a lot of things. I think for addressing stat anxiety, we should be given more time to absorb things. Fear of misinterpreting data. For this, I mean, suppose I have been given a Bayesian project where my teacher or my professor asked me, go and find the data and work on it. And now if I started misinterpreting a wrong in the beginning, I will end up with the 0 grades. Now, I know all of us here are good statisticians or in the journey of the same, and we know what Markov chain means. But if I ever get a chance to teach some students about what Markov chain means, I'm going to do it, or I'm going to demonstrate it through the Markov the mouse journey simulation. I'm assuming Markov can either go in room A, room B, or room C, and I'm currently assuming Markov is in room A. So I'm going to ask my student to spin a random number between 1 and 100. If the number comes up between 1 to 10, that means 10% probability of staying in room A. If comes between 11 to 70, 60% probability of staying in room B. If comes between 71 and 100, that means 30% probability of staying in room C. Similarly, I'm going to simulate it for room B and room C, and this is going to help me calculate these transition probabilities. I will give my 5 students 5 turns, and each turn they will get some random number generated between 1 to 100, and these are the random numbers that showed. I just took them voluntarily, assuming I am those 5 students. So starting point was room A, and summary of the Markov journey. Markov visited room A twice, room B thrice, and room C once. If we're going to repeat this process for many more turns, we would eventually see a pattern where Markov spend more time in some room than other. And that's the concept of steady state distribution, where the probability of being in each room stabilizes over time. Now, have you guys ever wished for a personal tutor who could adapt to your pace and give you instant feedback? That's what AI-powered personalized learning assistants can do. And that's really amazing. That's why they're dancing. Assistant teaching Markov chains. So basically, these can help. We're going to just give a prompt to AI, help understanding Markov chain. AI going to ask us a few questions, we're going to respond, and then AI will help us to give further explanation that can help us to understand the basics more. And if we're going to incorporate these in our education, that can be really helpful. So mitigating stats anxiety can be done through personalized learning support, giving more time to absorb things, as I said before, reducing grading pressure, incorporating interactive and engaging learning, and creating a supportive classroom environment. Stats are the heart of research, but confidence is key of understanding them. Overcome the fear and the numbers will speak for themselves. Addressing stat anxiety is essential for creating a positive and effective learning environment. By incorporating interactive tools, personalized support, and fostering a growth mindset, educators can empower students to overcome their fear and engage more confidently with stat concept. At least this will work for me. Thank you so much. Thanks for giving me this opportunity.
Thanks very much, Kunj. That was really interesting. Our next speaker is coming from Hobart. It's Melissa Middleton, and they'll be talking about their career experience, PhD to postdoc, tips for taking the next step. Go ahead, Melissa.
Great, thank you, Daisy. So like Xi-Ching, this will be a little bit self-indulgent. I'll be talking a lot about myself and my experience, but unlike Xi-Ching, I'll be talking a lot about my failures and what I did wrong when I went from my PhD to my postdoc. So hopefully you can learn from my mistakes. So I will start by finding out how to change the slide. So I'll start by giving you a brief outline of my career journey as a statistician so you can understand my experience and where I'm coming from. I'll then talk about the similarities, but mainly the differences between a postdoc and a PhD. And then I'll go into my 3 biggest hurdles that I faced in that first year. So for me, I started my statistics journey back in 2017 when I started a Masters of Biostatistics at the University of Melbourne. Following this, I was really keen to jump into doing some applied work, and I did this at Monash University, working mainly in observational studies. Now in this role, I was just doing everybody else's work. I was a person that they said, hey, can we do this? I said, yep, give me a minute, we'll get the results, we'll publish a paper. After a little while, I really wanted to start leading my own research, and so I started doing a PhD in 2019, focusing on missing data methodology, again in observational studies. I completed this at the start of last year and jumped straight into doing a postdoc research position at MCRI. However, this time I jumped from observational studies to clinical trials and started working on adaptive platform trials. And that's where I've been for the last year and a half. So when I was a PhD student, I thought postdoc will be very much the same, right? They're both academic positions, they're both research centered, and there is still a lot of skills development focus in your postdoc. I just thought it would be great to have a little bit more money from a postdoc salary. However, when I was in my PhD, I felt often at times that I was in my own little PhD bubble. I was working solely on my research with very minimal collaboration outside of my supervisors. The PhD program had clear goals and milestones of what I needed to be completed and when that needed to be completed. And I had a lot of support and guidance from my supervisor team, particularly at the start. There was a lot of hand-holding in my experience. There was also, depending on the PhD program, you may have some coursework and some hurdle requirements. Now, these last 3 points you don't have in a postdoc from my experience. So you still have that self-directed research, however, it isn't the main component of your workload. You now have collaborative work as well. So I started working collaboratively on trials, and all of a sudden I went from being in my bubble to having a lot of people around me asking for a lot of different things. So this became a real balancing act, trying to manage my work as well as the expectations of others. On top of that as well, as a postdoc, you're expected to start contributing a little bit more to the research community through things such as grant writing, peer review, community involvement. So it does become this real balancing act of all the different expectations that you have. So this leads to my first hurdle, so time management, and then within that, people management. So up here, I have a matrix that is modified from the Eisenhower matrix, where we now have important to you, tasks that are important to you, and tasks that are important to others. And this is a way of prioritizing your tasks that you have to do. So if it's important to everyone, obviously we do it. We do it now, we get it done, everyone's happy. Where it comes a bit tricky is if something's important to others, but not so much important to you, it's suggested to delegate these tasks. However, as a young postdoc, we don't really have anyone to delegate to. So we need to find time to schedule this workload. As well as this, the tasks that are important to you, but not so much to others, you need to find time to schedule this workload. And then if it's not important to anyone, they say just delete it. We don't delete it, but it's something that can just sit in the back of your mind and you do down the track when you have some time. So for me, my biggest problem was that I didn't prioritize the work that was important to me. When you start collaborating with others, you'll find that the tasks they give you, everything is important, everything is urgent, and as your role is to work out how actually urgent and how important that is and where to delegate and where to schedule that time. So for me, I did a lot of their work, and ultimately, if I didn't do my work, the only person I was really letting down was myself. So I didn't necessarily do that. Along with this as well is I was a bit of a yes person, a little bit too much. Now, a postdoc is great for taking on opportunities and building your track record, but you really need to be critical around what you're saying yes to and what value that has to you. Because a lot of times things you can say yes to and take on may just be fluff tasks that don't actually add a lot to your track record or a lot of experience gained. So some tips I have is to set priorities. Make sure every week I look at the tasks that I want to get done. Normally when I write it all out, I realize I don't have enough time for this. So I pick maybe 1 or 2 tasks that I really want to get done, and they're the things that I focus on, they're my priorities. And if they get done, we then move to the next step. The next tip is to block out time. So this is really important for me. Because I don't prioritize the things that are important to me, I will actually block out a day that is my research day and I work on my projects. We won't take meetings on those days. I won't work on any of my collaborative work. I won't answer emails. I focus on my research. And the last 2 points go hand in hand, and this is about managing people to manage your time. So be realistic with deadlines that people give you, and start to manage their expectations. I will go into meetings as part of the trials I do. We have to do extensive simulation studies. I can go into meetings with collaborators and they will go, hey, can we add this, 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 and this to the simulations? And I say, yeah, we can do that, but you won't get the results for 6 months. And so all of a sudden we start scaling back. And once they see these clear deadlines of what is realistic, they start prioritizing themselves what they really want. So my next hurdle was imposter syndrome. So for me, imposter syndrome really hit hard at 2 points in my career. The first was at the start of my PhD, when I felt like I needed to know everything that all of my peers knew all at once. The second point that this happened was at the start of my postdoc, when all of a sudden I was dealing with clinicians who had been doing trials for many, many years. I was quite new to trials. Obviously, with their experience, they'd gained some understanding of the statistics that are required. And so I thought, oh my God, why don't I know as much as them? They know everything. Why am I here? But then I took a step back and I realized, well, they're paying me a reasonable amount. If they didn't need my expertise, I wouldn't be here. So I'm sure everyone's seen this kind of visualization. We have imposter syndrome of what we think. So it's usually that we believe that what we know is just a subset of what everybody else knows. We only know a small amount and everyone knows everything about everything else. The reality is often what's on the right here is that you have your information, you know, everyone else has their information. There might be some overlap. You may not know the same things, but everyone's got their own expertise. So some tips I have to minimize the impact of imposter syndrome is to avoid comparison. Often I will compare myself to very senior people in my workplace, or I will compare myself to other postdocs who are maybe 2-3 years down the line. We don't know everyone's journey. We don't know their experience or stories. It's really hard to give an even comparison, and it's not doing anyone any benefit. So just generally try to avoid that. The second tip is to acknowledge your successes and your failures. So for me, whenever I succeed at something, if I get a grant, there's always a little voice in the back of my head that says, oh, everyone must have got the grant. I'm the last person on the list, or maybe it's a mistake. I don't take time, or I never used to take time to actually sit there and go, no, I put in a lot of effort to this. This is a really good idea. I have earned this. I can celebrate this. This is what I deserve. On the same token, nobody talks about their failures. So for me, acknowledging your failures is really for everyone else, is that you want to be able to see that because everyone fails. It's an important part of learning. The last thing is to, again, talk to others. Knowing other people experience what you're feeling really helps to minimize the impact of it. My last tip, or my last hurdle, was finding a support network. So as I said, when I started my postdoc, I went from observational studies to trials. I also went from working predominantly in a Frequentis framework to now predominantly working in a Bayesian framework. And with that, I went from coding entirely in Stata to now being expected to code very extensive simulations in R, as well as coding very complicated Bayesian models in STAN. So it was a very steep learning curve for me. And as I mentioned earlier, when you start your postdoc, you have a little bit of a less hand-holding, and there's not a great deal of support. So finding a network, going to conferences like this, talking to people, you will be able to find people that you can include in your network and bounce ideas off. On top of that, having mentorship, and I know there's a session tomorrow on the SSA program's mentorship program at lunchtime. That was really useful for me, particularly having someone outside of my institute that I could discuss any issues that I was having and get an outsider's perspective. That was helpful. Finding peer support. So a lot of institutes will offer peer-to-peer group support. programs, or just talking to your other postdocs or peers in your network is really great as well to, again, just talking to others about your experience and what they're going through. And the last one here is asking for help when you need it and ask early. There is a great emphasis on postdocs being independent. And for me, that meant that I had to prove that I could do this on my own. So there was a couple of times that I had a very small problem that if I asked for help, it would have been solved really quickly. But I was so intent on proving that I could work independently that I didn't ask for help when I probably should have, and it delayed the project. So that's all I have. Thank you.
Thanks very much, Melissa. That was really interesting. Thanks, Melissa. That was really interesting. I will go to questions now. Before I look at the Slack, are there any questions in the room in Perth? No. Does anyone in any of the other in-person hubs have a question? Okay, we have a question in the Slack from Phoebe. Thanks, Kund. I relate to statistics anxiety so much. Do you think there are any other ways to overcome statistics anxiety other than AI learning tools?
Yeah, thanks for the question, Phoebe. I tried to answer it on the Slack, but I wonder, one of the best technique that I could apply while I will be a teacher or a professor, just turning concepts into game. That's being called as gamified learning techniques that can help students to understand the concepts well. I literally acknowledge the fact that professors are quite busy and it's not really easy to turn every concept into game, but I do acknowledge at least converting the basic concepts of statistics into games that can really be helpful for the students and can enhance their interest in statistic courses. Thank you.
Thanks so much. Anyone have another question? Trent, I'll bring you the mic.
Thanks for Xi Often we want to work with like the rawest data possible, but I imagine the data you're working with, there's a lot of it, and you probably have to aggregate some of it to answer any questions. How confident are you in the aggregation, or what type of aggregation do you have to do to sort of to work?
Yes, that's a classic question that a statistician will ask an astronomer, because we care a lot about how we procure the data, and that should influence how we analyze it. Basically, the pipelines, by the time the data reaches me as a statistician, as an analyst, it's gone through an intense pipeline. In fact, whole PhDs are just devoted just to going from voltages on some antenna to the final number and the standard errors. So I think that initially makes me quite uncomfortable when I was doing this sort of stuff, but I have to kind of just trust that the physical modeling that goes in, the understanding of the mechanisms of whatever is emitting the radiation that we're measuring, that all that expertise has gone into it to the point that I can just trust what's in the end. But naturally, they can't always pick up every issue. So we have to then, as statisticians, think of sort of robust methods, ones that can handle outliers or that sort of stuff. Now, the other thing I guess I should say about in astrostatistics is that our knowledge of the universe is actually quite poor. And so even an incremental improvement means a lot to the domain. And often that the amount of energy put into improving the data processing pipeline before it gets to statistician is somewhat of diminishing returns compared to what we can add at the other end. Yeah.
Thanks, Xi-Ching. That was a really interesting answer. I will ask a question if there's no more questions in any of the other hubs. I will ask Melissa, if there's any one piece of advice that you would give to someone maybe just starting their journey as a sort of self-driven academic, maybe before they've started their PhD or whilst they're in their PhD, what advice would you give to keep people's confidence up that you've learned throughout your journey?
So the number one piece of advice I would give would be to be kind to yourself. I know definitely I have that little voice in my head that's always self-doubting, always questioning everything I do. See if you can switch that off. The other piece of advice that is just as important is talk to the other postdocs in your department and just make friends with them, just talk to them. You'll start to have these conversations, and I think they will help boost your confidence, because once you get to know people, they kind of let their guard down a little bit. They can be vulnerable and they can talk about their failures, or they can talk about things that they struggled with as well. And that generally made me feel better about how I was feeling in my postdoc position and made me more confident in that, okay, I am doing the right thing here.